Morning, everyone. As I was introduced, I am Felipe Portella from Petrobras. I am a TI advisor for HPC for reservoir simulation. Currently, I'm also a PhD candidate here in UPC in partnership with the guys of Barcelona Supercomputing Center. What I will be bringing here to you today is a little bit about our infrastructure for HPC for energy industry. Why we use, not only in Petrobras, but in all other energy companies, HPC, how we evolved this infrastructure in the company, a little bit of our current clusters. I will detail why we have many nowadays, and a little bit about discussion for future trends in this industry, okay? So moving to the reason why the company used, but first a little bit of a quick fact about the company. So we are an energy company with focus in oil and gas and exploration, okay? And a reference in the word for ultra with deep water exploration. So typically what we have is what we see here, around 2 kilometers deep. We have the typical offshore wells where it's drilling a well to extract, and we have many wells, in fact, because we need to also inject some water or gas to keep the pressures of the reservoirs. But in the offshore of basins of Brazil, were discovered around 2000, the pre-salt reserves that we have this layer of salt about more 2 kilometers deep, and these traps well the hydrocarbons that are generated in this rock reservoir rock below. You need to imagine that these rocks are like a sponge with small pores where the oil are trapped, and we need to extract the oil from ranges of 5 to 7 kilometers deep. So just as a reference, Eiffel Tower is 300 meters. We are talking of more or less all the diagonal here, a well drilling all this long depth. So it's a very challenging engineering problem, and also it's a little bit costly because typically one of these wells can range from $70 to $100 million. And the company for the next years are planning to explore more than 300 of these wells. So we have two disciplines normally in all the energy companies. We have the geophysics, that you can imagine that are the guys who discover where are the oil. And we have also the engineer part that they deal of how we will extract this oil in the better way, okay? So we have two main workloads. One workload is for, I can hide this top bar. No problem. Yes, okay. We have these guys with the seismic processing, and we have in the other side the engineers with the reservoir simulations. These are the two main workloads. I will just give you some class here of seismic and engineer 101 in 30 seconds. Just for giving an idea of the huge problem. So imagine that we have all these 7 kilometers deep, and the geophysics, what they use hydrophones. They send a shock wave, and like an ultrasound, they will generate some images by the reflection of the sound. So this will generate an indirect image like we have here, and we need to do some processing. First, to reconstruct this image, and second, the engineer, the geophysics will enter to analyze and design exactly this blue line, the green line, the top and base layers, creating this big picture here of where the oil are. So the HPC will enter exactly to transform this kind of images in a model that can be used later to advance and explore these fields. In the other side, for the reservoir engineers, the challenges are many. So they need to decide how many wells they will put, where these wells will be located. We need to, as I mentioned, to inject something to keep the pressure of this reservoir, so keeping the production. What we will inject, how long we will inject, when we start to injecting, what will be the cash flow of these projects. So all of that are being made by reservoir simulations. So besides, of course, these two main workloads, we have many others: research, petrophysics, geomechanics, machine learning that you guys know well. But I will give some details about, computationally speaking, about the main 2-4 hours. So in seismic, usually it's a single precision problem, okay? And in reservoir, it's very important to be double precision. So this will define a little bit the need of different machines for each one. Also, in seismic, we have very large problems. We are talking about terabytes of data, while in reservoir simulation, it's usually in gigabytes size. Moving about CPU, GPUs, geophysics, exactly because of the single precision, started to use GPUs much earlier. We still have a lot of CPU processing for pre-processing of the data, but the biggest capacity, the biggest demand is on GPU. On the other hand, for reservoir simulation, no GPU. There are exceptions. I will talk in the future panorama that this reality changed a little bit nowadays. But it's the reality is that not that much GPUs are used for reservoir simulations. In the case of the GPU jobs, they are typically with InfiniBand. In the seismic, we use in Petrobras in-house development software. In the case of reservoir simulation, we have typically commercial apps. And in reservoir simulation, we have shared memory problems. So we are dealing here just with OpenMP. Usually it's just a single node for doing one of these simulations. There are exceptions. We have some MPI and others. But the issue is that in seismic, each job can take weeks, and here in reservoir, we have jobs that take a few hours. But for reservoir, we have dozens or hundreds of jobs. In the other hand, for seismic, we have just a few of them that can be using all the nodes, hundreds or thousands of nodes, okay? So just giving this overall idea of how we need to use the HPC for the energy, I will just, as yesterday we have some history, I would like to bring today also some history. So in Petrobras, we started in '69 with a mainframe for seismic processing. Of course, at that time, this was not called HPC. And from around the 90s, we use mainframes for that. We evolved as many other industries using RISC machines, and most of our clusters started with Beowulf, with Linux, x86 architecture. I don't have a picture of the first cluster in '97, but this was the cluster that we had in '99 with 72 desktop machines there, very artisanal these, but quickly we evolved for more big infrastructures in a data center with 1,000 CPUs in 2004 and 4,600 CPUs in 2005. And by that time was exactly more or less when we have the discovery of the pre-salt. And the discovery of the pre-salt put pressure because the problem of the geophysics grow incredible, more than 20 times. So just running in CPU was not anymore possible, and we started the research of how we can evolve this to other architectures like GPUs. But nowadays we know that the GPUs is the standard for that. But at that time, there are other technologies interesting as well. One of that we had was PlayStation 3. Yes, we purchased 4 PlayStation 3 and make a small cluster as a prototype, as a research to evaluate this technology. We have a paper here with reference. Later you can check in the web page of the event for more details, comparing the architectures also with the Blue Gene that we were considering at the time. Of course, you know who won this battle. We moved it for GPUs, and quickly what we had was machines at the company with GPUs in 2008. And we quickly expanded from 1 to 3x in the next year. It's interesting to note that this started in 2008, and in the cloud, we only reached to use GPUs, they are only made available in 2016. Petrobras likes, from that time on, to give names for the machines. This was the Grifo 01, and we have some artwork, not so cool like the Pokemons from yesterday, but we like this kind of artworks. And the GPUs bring to us more than X gains in terms of performance per cost, performance per watts, space in the data center. The GPUs of that time were very good for the floating point 32, but not for the 64. So it was not ranked for top 500 or something like that, but this was the beginning of the big clusters that we had in the company. We had in 2012 the Grifo 04 expansion to 1,000 Maxwell GPUs in more than 500 nodes. And this put the machine into the biggest ones in the oil and gas industry for that year, and also for Latin America, and stayed in that position for some years. But nothing in this industry, we deal with the price of the crude oil, and the crisis make the plans of the company to invest in the infrastructure to put on hold for some time. You know that HPC infrastructure quickly can be deprecated, so our infrastructure was almost obsolete by 2018, and we built a plan to revamp, but this was decided to be in waves, which lead to some fragmentation that we will see in the following slides. So what are our current infrastructure? To show the current infrastructure, first I would like to talk about our research center. It's located in Rio de Janeiro, okay? It's the largest applied research center in Latin America. We have more than 300,000 square meters of research center. This lower part here was the original site, and in the other side of the street was the expansion in 2010. And exactly when we did the expansion, we created there a data center. Before, the data centers were all spread among different buildings of the company. And it's more than 2,000 square meters data center with 10 megawatt capacity that mostly hosts the HPC infrastructures, okay? It's not enough for all the infrastructure that we had, so we also have a co-location data center with a third-party company. It's more or less 10 kilometers from the research center, but both are located in Rio de Janeiro. We live there mainly the clusters for seismic. So with this revamp, first just saying that about that other workloads that we have, this is the cluster for the research center. Some technology that we discussed yesterday, we use a Singularity there. We are talking just now for the year 2020 when this cluster was, in fact, we started the purchase a year before. InfiniBand EDR was good enough for the research proposals. And right now, as we speak, the guys are installing a new machine, mostly for geophysics machine learning research, of 7.7 petaflops with A100 8 gigabytes. Looking for reservoir simulation, nowadays we have more than 1,200 nodes. We are installing, as we speak, the same of more than 400 nodes in a new cluster called Albuquerque. This is all managed and for the end user saw as a single Slurm clusters. We have the partitions as optional, and we direct automatically for the different partitions. And as I mentioned before, right now we don't use GPUs for that kind of workloads. And the main seismic clusters that are the clusters that put Petrobras more known for this HPC infrastructure and the fragmentation that I mentioned. In 2019, we have Phoenix with 5 petaflops. In 2020, Atlas with 9 petaflops. Dragão in 2021 with 14 petaflops, and more recently we had Pegasus with 42 pegaflops. This put the company also 4 years in a row as the biggest machines in Latin America, also in the green top 500 and in the top 500. So a little bit more details about Pegasus, the biggest machine. We have more than 2,000 NVIDIAs and 8100. InfiniBand, in that case, we do benchmarks, we evaluate, and we decided to evolve for HDR. We really use for the seismic, the communication among the different nodes. It's important that we have more than 20 petaflops in this cluster for file system. So nowadays, the company have around 8 petaflops of total capacity among all the clusters that we have. And looking for the oil and gas industry, of course, top 500, not all companies put the machines there, but it's a reference to see that the company and the others are growing in the investment. And as we visited yesterday, Barcelona Supercomputing, just a quick comparison of the industry with the machine. Mare Nostrum 4 that you visit inside the chapel is 14 petaflops machine, and we are talking about Mare Nostrum with 300 more than 300 petaflops. So the whole industry, the public data available for the industry of oil gas is more or less the size of the machine. This is a very, this pre-exascale machine is really relevant compared with the market and the industry. That's one of the biggest demand industry. So besides internal clusters, the company also invests academically speaking in universities, in partners that we have along all the country. So we have mainly 2 big investments in 2019, a 5 petaflop machine called Santos Dumont. Santos Dumont is the father of the aviation in Brazil, by the same time as the brothers Wright, and he used to use this hat. So it's a nice infrastructure placed in some containers. In the back we have all the infrastructure of batteries, generators, etc. The machine is Atos machine inside the cluster that you can see here. And this provides HPC resources for more than 300 users in different institutions among all Brazil, that are universities that do research for the company in the oil and gas industry. And we also have Ogibon, 1.6 petaflop machine for geophysics research, the same kind of proposal. It's less restricted, the number of institutions that do the research for that. That one is the general for all the kinds of research, machine learning. It's a multi-propose machine. We have GPU and CPU partitions. This node, this is specifically designed only for the geophysics research. Well, talking about future trends in this industry. Cloud, that I didn't mention much before. Of course, it's very important, brings a lot of opportunities, but it's expensive if not used with care. We have some challenge for things like seismic that we run for months. We have a very well planning of which areas we'll be evaluating. So for that, we can do in advances exactly what we are doing. We can purchase machines, put on premises, and we have much lower cost. We have all the infrastructure, so it's more challenging to go for cloud for that. But there are more suitable, like the reservoir simulation. Per day, we have hundreds of jobs, and we have this kind of peaks. This here, I think that are 3 days, yes. And you can see this is our reservoir cluster. The 1,200 is this green line here. And what we do is that we use the cloud, more 600 nodes in the cloud on demand to submit when we have the peaks of the users. Okay, so we do this automatically. It's just another partition in our cluster Slurm that we just move the jobs when needed. The user can submit directly to that partition, but if needed, we just move these demands for the cloud. Cloud also is giving us opportunities to use the accelerators for machine learning, like the TPUs, the AWS training and other hardware that's interesting. But we are still missing a lot of opportunities. We want to use some data caching, so nowadays we are using the cloud in Brazil region only. We want to explore other regions, so this is important. We want to use Spot, multi-cloud, so there are other opportunities that we are still missing. About quantum, the same way, we think that we need to be quantum ready. We had a lot of workloads that some of them will be good. We have here a paper of quantum annealing with seismic inversion, but what we are doing now, as we were discussing, it's good to invest in that. Right now, for a company, an industry like Petrobras, is just to be quantum ready, use the quantum resources like AWS bracket, and move forward in that direction. HPC as a service is something that we are trying to change this in the reservoir community, because GPUs are being introduced as we are speaking some of the products. This brings new complexity to the end users to manage which number of nodes, if I need to go GPU or MPI or just one node, if I should use cloud or not. So, and also the end user many times decide that, okay, I may be using all these resources to speed up my simulation, but when we look for that big panorama, I need to optimize globally. So it's a research project, it's part of the PhD that I'm doing, exactly to be agnostic of this underlying infrastructure here. We have a logic that will decide how many cores we will use, which is the best speed up that we can have this using which kind of hardware, and decide for which architecture to use, all the details of the underlying configuration. So just concluding here, the HPC is very important for this kind of industry. We started back in '69. We use mainly x86 Linux clusters. We expanded very heavily by more than 20x since 2008, and we will keep investing and growing the on-premises HPC for us. I open to questions. While I am answering, I will leave a video here for our biggest infrastructure, that's Pegasus.
Awesome, thank you so much. Okay, just highlighting the complexity around moving to cloud as a cloud bursting. So as you mentioned, we have seen a lot of people trying that, and if you don't do it properly, so it becomes really expensive really quickly. So I was wondering, I noticed the peaks of demand on the cloud. Do you have any mechanism to implement business rules for those kind of workloads that are suitable to be run on the cloud?
Yeah. Right now, the cloud queue is like closed. The users can submit, or we can. But what we do is that there is a group of the company that analyzes the importance of having these projects really evaluated in the time that they are required, and to move them to the partition in the cloud to have this cost. What I'm doing this research project is exactly to automate some of these business rules that the guys have, and ask to put an SLA into the jobs nowadays, because we know from which user, from which project we are running. So we have this kind of information embedded, but it's not going nowadays for our Slurm queues. So we need to track this information and automate this kind of decisions. So nowadays it's doing manually, but we are moving forward to automate this kind of decisions.
Have automated that part. But the missing component is still the data staging, which is also part of the... Awesome. Any more questions? Yes, one over there.
Hi. How do your applications scale? I mean, both in the seismic department, so to say, and the reservoir. I mean, how many nodes do your applications scale? And you have also mentioned that some of the workloads are using a single node.
Yeah.
Because they are using just OpenMP. So can you explain a little bit in order to make up my mind and figure out the
Okay.
kind of infrastructure you would need.
Okay. We have two words completely different. Reservoir simulation, it's single node, OpenMP, so just one node, doesn't scale bigger than one node. Usually the application scales to all the cores inside that node. We are using 40 nodes nowadays. The new cluster we evaluated and the application scales well inside a Xeon with 64 cores, so we are scaling using all the node. What happens is that we deal with uncertainty. So the engineer doesn't deal with one model. It deals with 100 realizations of that same model at the same time. So it's not just to decide where I will drill the well. It's one simulation with 100 possible variations of the subsurface. So I start by 100 models at the same time. And over that, we have processes like Kalman filters, optimization, that instead of just doing one, we have 50, 200 runs of all these models at the same time. So this brings, for the reservoir side, the demand of many jobs running at the same time. In the other side, seismic scales very well. We have like more than 1,000 GPUs simulating just a single problem. So it scales very well. For that, InfiniBand with high speeds is important. We use NVLinks inside the nodes. We have high density. In cloud, we did a very nice experiment with some machines with 16 A100 in a single node that scaled better to reduce a little bit the latency in the communication among nodes. So it's a very nice problem, and we have a lot of in-house development exactly to optimize the kind of communication and reduce this kind of things.
And I also get, so it's a matter of throughput of number of jobs per day that you can run, and I believe that it might be also critical the access to storage, parallel storage, right?
Yeah, yeah.